Let's talk about NAT and port forwarding. Network address translation, or NAT, N-A-T, is the process of modifying IP addresses that cross a router. Generally, this functionality is built into your router, whether it's a large black box used by a corporation or a basic 4-port SOHO router. And what it does is it hides an entire IP address space. In this case, in this diagram, the 10 network, the private Class A 10 network of computers. And so whenever one IP address, whenever one computer, say this laptop, wants to communicate with servers on the internet, that information will be converted. That IP address, every packet dealing with that IP address will be converted to this, the public address of the router, 207.172.15.50, or whatever public address was assigned to that router by the ISP out on the internet. And so what these servers will see and what all the external users will see is this address. They will not see the internal LAN addresses on the 10 network or whatever private IP network you're using. This way, it looks like the router is the only device making the connection to other systems on the internet. It provides safety for the computers on the LAN, and it allows a single IP to do the work for many IP addresses on the LAN. Now, these computers can still all communicate with the internet at the same time. Every time one starts a session with a server on the internet, the router remembers that, and it applies an ID to that communication session. So say the laptop wants to communicate with this server, this IP address is converted to this, but the router applies an ID for all those packets for that session. So it knows when the server communicates back through the router, it knows to send that information back to this LAN IP address. Now let's talk about IP addresses and ports, because every time you connect to a server, you want to connect to a server on the internet, you have to do that via a port. For example, if this was a web server, you would connect to that server through its inbound port 80. Okay, let's bring up a graphic of that. Here's a laptop on the 172.30 Class B private network. It's going to use an outbound port to go out through the internet to communicate with the server. In this case, we're saying port 3266. Doesn't really make too much of a difference what this outbound port is, because that's dynamically assigned by TCP/IP, and that'll change every time you connect. Every connection you make will use a different port number. What's important is you connect to the server on its inbound port, for example, port 80 inbound for a web server. And so you have the outbound port from the computer, the inbound port to the server. Now we can show this in a command line. This is a netstat command that was run, and you can see lots of ports here coming from this computer. It's making lots of connections to other remote systems on the internet. And you can see these dynamically assigned ports in the 55,000 range. Remember, you can have 65,536 ports total. In fact, you do have that many ports total on your network card. And a lot of those upper ports are reserved for dynamically assigned outbound connections. So, we have a connection here, 55777, going to a web server, 208.80.152.2. How do I know it's a web server? Because it's using port 80. You see that colon after the number, the colon after the IP address, that means that a port will follow that. Here's port 55778. That's connecting to the same server, the same web server. So is this one, and this one, and this one, and this one. When you make connections to web servers, you might be making multiple connections to see the web page, because there might be internal components of the web page that require different sessions, advertisements, instant messaging. There's all kinds of things that could be going on that web server. And in this case, there's actually 6 connections to that. Then we have a separate connection to 152.118. So more connections on .80. And over here, you see a connection from this local computer, again on the 10 network in this case, using port 55768. That's connecting to a different server, different IP address, 216.97.236.245:21. So we know the inbound port over there on a remote computer is FTP. And this was all done with the netstat-n command, or numeric, so you see IP addresses instead of host names. That's what you want to see as a tech most of the time. And remember, you have your outbound computer, you have your local computer and its outbound port it's using, which is dynamically assigned. And then the remote computer, the server you're connecting to with the public IP address and its inbound port that it's using, like 21 or 80 or 110 for POP3 email connections, and so on. Now let's talk about port forwarding. Port forwarding is when a router forwards a public request, an IP and a port, to a private IP and port on the LAN. So let's say there was a user out here who wanted to connect to a special server that was running here on the LAN, but you don't want to have the whole LAN be compromised. You just want to have a special port forwarding happen from this public address out to this server. So what this does is it forwards an external network port to an internal IP address and port. So let's say this guy here was running FTP, he'd have inbound port 21 open. If a person on the internet wanted to connect to that FTP server, what they would be told is to connect to 207.172.15.50 because that's the public facing IP address, :21, and then that router would see that request and forward that to this guy, 10.0.0.3, :21. So this enables you to have a web server or FTP server and other servers, but you need to have only one port for each open on the WAN side of the router. It could be any port you like, but generally it should be the default port so people can easily connect. If you make it a different port than the default, you'll have to tell them so they can change that in their settings when they make the connection, whether they're doing a HTTP or FTP connection. Now, this is a good way to do it. Port forwarding is important. You need to know how to do it. But a better way to do what we're talking about here is to use what's known as a DMZ, or demilitarized zone, and have a separate connection to your firewall or router over here, therefore protecting the LAN and keeping your servers on the DMZ. And we'll talk about that later in this lesson.